pipes network. How do you control drinking water quality? Conventional approach. Anybody? Well, the conventional approach for many, many years has been to test the drinking water throughout the distribution network and at the point of consumption for those parameters, as you have just mentioned. And if we find that some parameter exceeds the standards, we'll try to find out why. Look at the system and see why. What's going wrong? Why are the standards being violated? And that has been the conventional approach. But that is like the doctor waiting for the lab test, waiting for the urine test, waiting for the blood tests before he tells the fellow to lose weight and stop smoking and stop drinking. Got that? If you do that, it's going to be 24 or 48 hours that people are drinking contaminated water because it takes you that long for the lab results to come back. Okay. Water and health. Here's a bunch of depressing statistics about the burden of disease caused by unsafe water. 1.7 billion cases of diarrheal disease each year. Diarrhea kills around 760,000 children under 5, mainly in developing countries, and mainly poor children who are malnourished. So on and so on and so on. Now, what's curious, this shows drinking water coverage by regions of the world from 1990 until 2011. There's some more recent data that's available, but not too different from this. And it shows, except in Oceania, which is basically the Pacific Islands, and except in sub-Saharan Africa, in every other part of the world, the drinking water coverage is pretty high. It's usually like 90% of the population has access to safe drinking water. It's supposed to be safe. So if that is true, why is there so much disease due to drinking water? This is a graph from Japan, and now next we're going to see Thailand. And very interesting because the situation is quite different. Okay, this shows the growth in water supply coverage or access to water supply in Japan over a 100-year period, more than 100 years, from 1900 to the year 2000. And the blue line is the water supply coverage. It goes up to almost 100% during that period. The red line is waterborne diseases, and it's very variable. This is World War II, but comes down to almost zero. And that's what you would expect, right? As the access to water supply goes up, you would expect waterborne diseases to come down. Correct? Yes. Logical, right? It didn't happen in Thailand. There's a lot going on here. This is food poisoning. This is enteric fever, which is related to sanitation, not water. And this is dysentery, also related to sanitation, not water. But this line here is acute diarrhea. And this line is the percent of households with clean water supply. And very curious, it's exactly the opposite of what was observed in Japan. As access to clean drinking water went up, acute diarrhea also went up. So it's very curious. We have to ask why. This graph was prepared by the Ministry of Public Health of Thailand. And their thesis, unproven, but they believe it's because this drinking water is not safe. If you know Japan, Japan is a highly regulated country. And you can bet the drinking water is safe in Japan. But in Thailand, at the time of this study, only 50% of the water supply samples taken throughout the country complied with national drinking water quality standards. So the thesis of the Thai Ministry of Public Health is that the reason for this is because actually what has gone up is access to piped drinking water. But piped drinking water is not synonymous with safe drinking water. Anyone ever heard of this before? The WHO guidelines for drinking water quality? Anyone? A few people? Have you seen this publication? Okay. This was first published as far back as 1958, and there were several editions of that. At that time, it was called International Standards for Drinking Water. They stopped using the term standards and started using the term guidelines in 1984 because, in WHO's way of thinking, standards is something which is legally enforceable, and the WHO guideline values are not legally enforceable, so they call them guidelines. The key feature about this is that in 1958 they started, I think, with about 12 parameters that water suppliers should test for regulatory authorities. And every time there was new addition, it went up to 20 parameters, 30, 50, and now there's more than 200 parameters for which guideline values are set. And these are used by almost every country of the world as a reference point in developing the national drinking water quality standards. Most countries cannot test for 200 parameters. It's just impossible. So you have to prioritize. The other key point is that starting in 2004, the water safety plan concept was introduced into the guidelines. And this is what we were talking about, the doctor. You don't have to wait for the lab tests to come back before you tell the fellow to lose weight, stop smoking, stop drinking, and start exercising and improve his diet. With a water safety plan, you can monitor the operation of the water supply system, and you can see if a water quality problem is going to occur or is occurring before you get your lab results back. And you can take corrective action immediately. The WHO guidelines, as it's mentioned here, they're used worldwide. They're the scientific basis for developing national and regional standards, like the European Union standards. Sometimes used in the absence of national standards, although that is not appropriate. Countries really should develop their own standards using these as a guidance. Despite the wide application of the WHO guidelines for drinking water quality, in all countries at every level of social and economic development, even in the first world countries, waterborne illness still occurs, both related both to microbial parameters and chemical parameters. These outbreaks show us that we cannot rely solely on water quality indicators. We cannot rely solely on testing the water and waiting a day or two for the lab results to come back. By that time, people are already drinking contaminated water. Or as we say here, output monitoring is too little and too late. In another way, you can say it's necessary but not sufficient. What are the problems with output monitoring? Number one, notification comes too late. A famous example is from Walkerton, Canada, where 7 people died. I believe this was cryptosporidium. The water was being tested regularly by the water supplier. The results of the test were being submitted to the health department. But the response to the test results came too late. And the same is true for most types of water quality analysis. Number two, the testing and the standards are very narrow. Compliance with standards does not equate to absence of risks. What we want to say here is that E. coli is a very imperfect indicator of microbial water quality. A couple of examples are mentioned here. There was an outbreak of cryptosporidium in Milwaukee, in the United States in 1993, in which 400,000 people were affected. I think this is where the writers of the Batman movies got their idea for the Scarecrow. And in Nagase in Japan in 1996. E. coli was 0 at the times of these outbreaks. But the water was heavily contaminated with cryptosporidium. And the third problem with output monitoring, especially in developing countries now, is that laboratory capacities are often inadequate. There's not enough labs, there are not enough locations. Laboratories are very often lacking in hardware, in software, and in human resources. So we cannot rely on lab testing alone to control our drinking water quality. WHO's response to this situation is to rely less on output monitoring, in other words, measuring the parameters in the final water, and to rely more on input monitoring, to monitor the determinants of the drinking water quality, to monitor the things that cause the water to be contaminated. If you think about that doctor, somebody should be monitoring that guy's weight. His wife should be watching his diet and telling him, hey, put down that drink, stop smoking. The WHO guideline values can still be used for verification of water safety. In other words, we don't say stop testing drinking water. We don't say that. But the water safety plans should be the principal tool to assure safe drinking water. What are water safety plans? Quality management systems based on risk assessment and risk management of water supply to deliver a more consistent quality through system surveillance. Now, if we think back to that fellow who visited the doctor's office, the doctor's going to tell him everything we said. Go home, start dieting, stop smoking, cut down on your drinking, exercise more. And if his wife is in the waiting room, he's going to tell her, ma'am, come in here. I want you to watch him at home. I want you to monitor him at home. She's not going to be monitoring his blood or his urine. What's she going to be monitoring? His diet, whether he's smoking, whether he's drinking, how much he exercises. Can monitor some quantitative issues like blood pressure, because you can measure your blood pressure at home. It's kind of like taking a chlorine residual test, right? You can get the results immediately. Not send that to the lab, you can get the results right there. Water safety plans identify the risks to the water quality and the water supply system from source to consumer. Typical water supply system has a source, a conveyance structure, which conveys water from the source to the treatment facility, then the treatment facility, then a distribution system. Usually we think about pipe distribution systems, but there may be other distribution systems. Maybe distributed through tanker trucks, maybe distributed in jerry cans, maybe distributed in bottles like this. This comes through a distribution system, not a pipe distribution system, but it's a distribution system. And the last part of the water supply system is the consumer's premises, where water is used on premises, because very often water is stored on premises, and unsafe handling practices in the home may also be a source of drinking water contamination. There are risks at every stage of the system. Water safety plan simplified. It's a continuous cycle of asking, what are the risks in my system? How do I control these risks? And monitoring the control measures. A water safety plan needs to be specific for each system. It's system-specific plan. And it needs to be continually updated. Why? Why should a water safety plan be updated. Not continually, but periodically updated. Somebody? The system keeps changing. Sorry? That's right. As the system changes, the risk changes. Distribution systems are expanded. Maybe a new well is installed to increase supply. So the water safety plan has to be updated to keep up with those changes. Yeah, here you can see this is a schematic diagram. Typical water supply system has a source, a conveyance structure. Here there's raw water storage. This could be an equilibrium basin, some kind of a treatment process. Sometimes the treatment is simply disinfection if the water source is very pure. And in this particular one, there's a clear water pond, and then it goes to reservoirs and the distribution system. Not shown here is the user's premises, but this is also a very important part of the system, what happens at the user's premises. And as we said, there are risks all through the system. In developing a water safety plan, you need to look at your specific system from the source to the consumer and identify what are the hazards, what are the risks in your particular system. What about these terms, hazards and risks? A hazard is simply something that can do harm. It's a biological agent, a chemical agent, or a radiological agent. A hazardous event is an incident or situation which can expose a system to a hazard. It's an incident or a situation by which one of these hazards, biological, chemical, or radiological, can enter into the system and contaminate the system. Do we all have the concept of risk? What is risk? Have you covered risk? What is risk? Risk assessment? Anybody? Anybody want to explain what is risk? Risk? Tell us. Speak loudly so everyone can hear.
We have to behave risk on something hazard or bad. Affect all hazard harmful things around us.
Mm-hmm.
Our behavior doing around this.
Okay, something. Anybody else? Risk?
Hazard into intensity by capacity.
Sorry, say again?
Hazard into intensity by capacity.
Okay, I'm not sure what you mean by that. There's two key issues here. The likelihood that something will occur and the severity if it does occur. Somebody explained it to me like this. I think the planet Earth is 4.5 billion years old, something like that. During that time, there was a major catastrophic incident where a large asteroid or meteor hit the Earth, caused a huge dust cloud, and killed all the dinosaurs. So the likelihood of that an asteroid like that hitting the Earth is very low. It only happened once in 4.5 billion years. But the severity, very high. I was in a workshop recently, a 5-day workshop in Indonesia, and I said to the participants, you know, the likelihood that one of us has an upset stomach this week is very high. I'm sure somebody here is going to have an upset stomach during the week. Likelihood was very high. But the severity, very low. So one person has an upset. So that's the concept of risk. It's the likelihood that it will occur and the severity. There's a reason why I'm showing you this, okay? These are the likelihood categories defined by WHO in the Water Safety Plan concept. If something is almost certain to occur, we say it'll occur once per day. We say it's likely to occur once per week, and so on. And then the severity. We say the severity is catastrophic if it has it's potentially lethal to a large population. This is something like the scarecrow, right? Poisoning Gotham City. It's major if it's potentially lethal to a small population. The severity is moderate if it's potentially harmful to a large population, and so forth. Now, why did I show you that? This is how we prioritize risks in a water safety plan. This is called a semi-quantitative risk analysis. When we have identified all the risks from the catchment to consumer, we can do a ranking system. We can ask ourselves, for example, what's the risk? What's the risk that we'll run out of chlorine? That some water will be not disinfected? First of all, what's the likelihood or frequency? Is it almost certain that this will happen once a day? Is it likely that this will happen once in a week? Is it moderate likelihood? Will it happen once a month? They're very unlikely. Like, we think this might happen once a year. Or is it very rare? This is something that will happen once every 5 years. And who will know best? Will be probably the operators at the water treatment plant, because they will know, did this ever happen before? So this is how we judge the likelihood that our treatment plant will run out of chlorine. And then what's the severity? Suppose the treatment plant does run out of chlorine. Will the severity be insignificant? In other words, no impact or not detectable? Will it be a minor severity? This is defined here as a compliance impact. In other words, we'll have to admit we didn't comply with regulations, but other than that, really not a problem. Will it be a moderate impact, defined here as aesthetic impact? Will the impact be major or catastrophic? And then if you multiply, this is given at a rating of 5, 4, 3, 2, 1. This is given a rate of 1, 2, 3, 4, 5. If you multiply 1 times 5, 5. 1 times 4, 4. You see how this works. So this way you can prioritize your risks, and you see which are the most important ones that you have to address really urgently. They're the ones shown here in pink or red. In the yellow zone, we have moderate risks. In the green zone, we have low risks. Because when you analyze your system and you analyze all the risks from catchment to consumer, it's likely that you're going to find a lot of problems there. So you need to prioritize them and deal with the highest risks first. There are some worksheets that have been developed. This worksheet happens to be used in New Zealand in small community managed systems. This is, in this column here, you list the hazardous events that you think could happen in this system. And some examples are given here. For example, it says a slip. A slip is a small landslide. A slip in the catchment causing deteriorating water quality. That would be a hazardous event, because if you have a landslide in your catchment area, what's going to happen to the source water? What will happen? Anybody? Yeah, turbidity will go up, right? It's going to put an extra load on your clarifiers and sand filters. And there may be other organic material that's introduced along the slip. Another hazardous event, leaking septic tank releasing bugs What does it mean, bugs, not insects? It means microbes. Another hazardous event, pending farm conversion upstream. Pending means that it's planned. There's a farmer in the catchment area who's planning to convert his farm. Maybe he's growing corn now, he's going to bring in livestock. And there could be others. You have to look at your own catchment area and see what are the hazardous events in yours. In this column we ask, is this hazardous event under control, and how? Slip in the catchment area causing deteriorating water quality? No, in this particular case that's not under control, so that's an issue. Leaking septic tank releasing microbes, is it under control? It says yes. The intake is upstream of the septic tank, so the leak in the septic tank will not affect the intake. Pending farm conversion upstream? No, not under control. In this column we ask, if it's not under control, judge whether it is a significant risk. That means likelihood of occurrence and severity if it does occur. There's a tick mark here. I think they're trying to say that this is a significant risk. Okay, is this a significant risk? The leaking septic tank releasing bugs, but the intake is upstream. Is that a significant risk? No. Because the intake is not affected by it. What about the pending farm conversion? The farm conversion is planned for the future. Is that a significant risk? It's not now, but it could be in the future, right? Okay, I'm looking at the clock, so I'm going to go quickly. This is a worksheet for the treatment process. I'm not going to go into it in this interest of time. This is a worksheet for the storage and distribution system. It's the same idea. Identify hazardous events in that portion of the system, identify the control measures, and make some judgment about whether it's a significant risk or not. Next step after you have identified the significant risks is to develop a plan to manage the significant risks. So here in this column we're listing the hazardous events. Remember this one? A slip in the catchment area causes deteriorating water quality. We identified in the previous slide that this was a significant risk. How can you remove or reduce this remedy, and by when? Well, in New Zealand, they planned that a warning system would be installed that automatically shuts down the intake. That was to be done. This is an old slide, you can see. Okay, until this is remedied, how will you know when this is actually causing deteriorating water quality? Visual inspection with vigilance during rain. Makes sense, right? When you have heavy rainfall, that's when a slip is going to occur. So until this control is put in place, you have to do this. Okay, what contingency is in place until this is removed or reduced? Who needs to know and how quickly? Who can help? The contingency is that there would be an extra stock of cartridge filters, in use cartridge replaced regularly. Okay, this is just an example. I want to emphasize that every water safety plan is system specific. What you have seen here was developed for one small community managed system in a remote part of New Zealand. Not every water safety plan is going to be like this. Okay, water supply situation in selected ASEAN countries. I've listed a few here. Cambodia, Laos, Philippines, Vietnam, and Thailand. Anyone here from Cambodia? Anyone from Laos? Philippines? Vietnam? Okay. A lot of people from Thailand. Okay, just this year in 2015, The Ministry of Health developed a regulation. It's called the PRAKAS, P-R-A-K-A-S, requiring all urban water suppliers in Cambodia to develop and implement water safety plans. Cambodia, according to this data, has 70 people who are qualified to give training on water safety plans. In Laos, water safety plans have been compulsory nationwide since 2004, despite the fact that there are only 5 people qualified to give training on water safety plans. In Philippines, it has been compulsory for all water supply systems, urban, rural, even the smallest community managed systems, must develop and implement water safety plans in the Philippines since 2004. The number of trainers who are qualified in the Philippines is not mentioned there, but I know there are quite a few. There are probably 10 or 20, maybe more like 20 people who are qualified to give training. In Vietnam, it's already compulsory for urban systems in Vietnam. It has been for a few years. There's a draft regulation which will make it compulsory for rural water supply systems. I think urban systems in Vietnam are regulated by the Ministry of Construction, and rural systems in Vietnam are regulated by the Ministry of Health. There are 175 people in Vietnam who are qualified to give training on water safety. Thailand, which in almost every aspect is a leader in the region, is behind in this area. There's no requirement for water safety plans in Thailand, and there are no people qualified to give training on water safety plans in Thailand. The MWA, Metropolitan Water Works Authority, does have a water safety plan on paper. It's not implemented. WHO and the MWA are soon going to sign a memorandum of understanding, and WHO will help the MWA to update its water safety plan and to implement it. The Provincial Waterworks Authority, with the assistance of Waterlinks is an international NGO, has been training its staff on water safety plans. So they intend to do something. I don't know exactly what their plans are, but they are training their staff on water safety plans. And I'm sure they're not doing that for no reason. Small community managed systems in Thailand that are not covered by PWA, I don't know what's going to happen to them. They're under the regulation of the Department of Health, of the Ministry of Public Health, and the Department of Health has no requirement for water safety plans. The Department of Health does have a program on community-based water quality monitoring, and they could build on that to build up a water safety plan program for community managed systems. But it hasn't happened yet. Anybody here from Singapore? No? Singapore only has one water supply system. It's very high tech, but they have a water safety plan that is implemented. And they may be the only country in the world that does monitor for all more than 200 parameters fitting the WHO guidelines. And they comply with all of these parameters. Indonesia has some pilot programs on water safety plans. Malaysia also has some pilot programs on water safety plans, but so far no regulatory requirement. Myanmar has some pilot projects. Brunei, I'm not sure. I'm not sure what's happening there. Have I missed any of the others? Korea, I don't know. What is the situation here?
What's the water safety content, including water regulation?
Including?
Water safety plan content already include regulations, such as drinking water regulation.
Okay.
We have a water pilot parameters that 59 parameters. 30 is 0.5 MT.
Well,
0.5.
And the CT all kind of improve.
Okay, so that's all I have to say about that. And for your homework, you have to go on YouTube and look up the Batman movie. See the one with the scarecrow. So, any questions?
Guys, in terms of preparations for exam, right? Well, we have something on that. Not exactly what a safety plan, but this is related to us, right? Remember what we were talking about, drinking water or wastewater. The waste component of wastewater here. Do we have wastewater? Terry never mentioned wastewater, right?
No.
Is there any wastewater somewhere in these lines? Is there any relationship? Well, look, in Thailand, Thai students, I had some students working on water safety plans, okay? And if I ask you Thai students, do you drink water in the corridor, in the drinking fountain? Do you drink it? Huh? Yes, said Indian students. Yeah, right. I'm talking to Thai students.
Sometimes.
Thai students, you drink that water? Was
Sometimes.
drinking water?
Yeah,
You drink
sometimes.
it? Well, some people, yes. Yes. Why? Government, remember what government says? Drink
It's
it.
candy.
Drink it, right? You say, yes. So, why? Okay, not sure. Why? Not sure. Government says, Prime Minister says, guys, I drink this water myself.
ทำไมถึงไม่กินใช่ไหม
Why not sure? With what?
Sometimes I
Remember that treatment plant? Where did you go? Banken or what? Right, good plant, huh? You happy? Clean water? You have lots of drinking water? So what? So bad water? What contaminated with what? Huh?
กินไป
What do you mean? Here's pipe goes, water goes, comes, you drink it. Where? Where is contamination?
ไป is cracks
So what?
sometimes right is
Okay, water flows out.
somewhere the pipe is cracked
Okay, cracks, water leak. It's a water leak.
water leak and the soil around the pipe is
But what can leak in? What?
leak.
Talking about my question, where's wastewater here? Is any wastewater connection? Okay, don't answer, you will answer in 4 days, right? We'll have it in exam. Okay, good one. Please, more question.
You have word
ก็ยังไม่เฉลยแบบเต็มๆอ่ะเข้าใจปะ
in developed country, what is the most important things for water safety? In developed countries,
In developed countries,
what is the most important thing for water safety? In regulation, technicals, there are many parts. What is the most important?
it's hard to say what's most important. Everything is important. Development of the plan,
คือจะมีไอ้นี่อยู่อันหนึงไอ้
Maybe auditing.
ไทยดี
I think
อะไร
auditing
สัก
is
อย่าง
very
หนึ่ง
important.
ที่แบบที่คูณกันอยากรู้ว่าทำไมห้า
It's
ข้างบน
the,
มัน
it's
ไม่
the
อยู่
water
ในเขต
supplier
บ
who
นเล
develops
ส
the
วะ
plan. The water supplier who implements
เอ
the
อ
plan.
เหลือง
But
เขียวแดง
there should be regulatory
แล้วมัน
oversight,
มีห้าที่
regulatory
มันเล็กไปอยู่ใน
agency
เขียวอะแต่อี
which
กห้าหนึงมัน
reviews
อยู่
the
ในเหลื
plan
อง
and approves it
ลืมเปลี่ยนสี
and monitors the implementation of the plan. Without that, the water supplier can put anything on the plan.
อาจจะครทีเรียข้างบนไม่สำคัญเท่าข้างล่างอะไรอย่างนี้นะ
What is compared to water quality standard? Example, in US EPA and Thailand water quality standard compared to water quality standard very different. Example in turbidity. In US EPA case is required to less than 0.1 mg. Korea. So we can benchmarking US in Korea. But Thailand case is less than 5 NTU. So this situation, we cannot expect is water safety in Thailand drinking water supply system.
You are saying Thailand cannot implement water safety plans?
In this situation, since NWA, PWA also have a standard, water
Yeah.
standard, turbidity 5 NTU.
Mm.
So if, three example, water treatment plant supply 3 NTU turbidity.
Yeah.
If tap water arrive in household 4 NTU or 5 NTU, in this situation, we cannot bring directly tap water. So I think either this situation, we cannot expect either water safety water.
Cannot expect the water to be safe.
Yes, because less than 1 NTU is very good case. But 3 NTU, 5 NTU, we cannot expect this disinfection. So in usually East Asian countries, turbidity is less than 5 NTU. So I think either water quality standard is required to more strict standard. What do you think about this in developed countries? What is the most important thing?
I think you're talking about standards,
Yes.
but I think auditing of the water safety plan is extremely important. If you ask me what's the most important aspect of the water safety plan program, I would say auditing by a regulatory authority. To review the plan, approve the plan, and monitor the implementation of the plan, and to ensure that the plan is updated periodically. NTU is also very important because this affects the effectiveness of disinfection. Any other questions?
Okay, guys, let's thank you for